attrition rate in energy is about 95% of failures, like from POC to just dead projects in AI, because the sustainment part is what people haven't figured out yet. And that's kind of, the system changes and the data changes, the maintenance happens, the catalogs, like the whole thing, right? That's where the real value is, and that's where people don't focus.
Technology is definitely, it's not the limiter in what's possible. I think that in organizations that I see today, it's around how do you incorporate these tools and these technologies into your day-to-day. And you can build a project and you can do a use case. But I think from that point, you have to stop and say, what is a portfolio of things that we have to do in order to sustain this in the long term?
Let's just say like the concrete and the plumbing has to be all done, right? But then somebody like me comes in and I'm sitting like, just think about it. Maybe I'm the guy sitting in the kitchen, like a sous chef comes in, the water's not flowing. Well, I'm dead in the water. I can't make any, I can't make any paella, I can't make any fancy pizzas or whatever. And so the idea over here is like, the last thing you want is the plumbing is not done. You bring an AI engineer inside and you kind of go like, oh great, I'm paying you top dollar, but the water is not flowing. So what do I got to do? I got to rip the wall apart, fix the plumbing to get the data. The analogy that I'm giving is that the plumbing is the data pipelines.
Yeah. You've got a few steps to do to introduce in order to grab the data, attain it, educate people on what that means, trust it, and then build the tools, technology side, to unlock the value that they're chasing. If you want to measure the value of a project, I push that back to them and say, what is the value of solving this problem for you? So if that problem is, okay, Mike, I think we can shave $2 to $3 million. Okay, show me how you would save that $2 to $3 million and where.
Yeah.
All you're doing is you're just narrowing down the problem that you're looking at and the question that you're looking for, because AI cannot solve every single problem in that chain. It can solve one of them.
Giving them visibility is like, sometimes it's as simple as like an Excel spreadsheet.
Yeah.
Right? Like you normalize SCADA data, sub-second to 5 minutes or 10 minutes, and you show them in anomalies and they dump it in an Excel spreadsheet and they analyze it and be like, oh yeah, there's the problem, right?
Yeah.
But there's one thing I want to just make it clear, right? That's reactive.
Yeah.
It's problematic because the damage is done. Like, what are you going to do now, right? We deployed an AI solution, 2 months. Nothing happens, right? It's for screen out detection. And then Joshua, who's just kind of sitting over there, it was a Power BI dashboard. So the output of the AI model was in a Power BI dashboard. And he sees like probability of failure, right? 50%. Like 20 minutes go by, probability of failure, 75%. So it's like kicking up. So he kind of like yells down and be like, hey, ease off on the pressure, right? Like by 5%. What happened was the PSI, pressure went up to 1,500.
Oh, wow.
Like that, right? So what happened was the formation wasn't taking the liquid very well. That's kind of how he explained it to me. And so the thing was, because of that, they were able to take predictive measures. And then we did the NPT analysis and everything. It was about 250K, right? And so it paid off.
Yeah.
For the very first model we deployed, they freaking hated it because it's like probability of failure, like WTF, like why? And the problem with that model was that it gave zero visibility of how it was coming up with these conclusions, right? Like neural nets are
Engineers
notorious.
don't like that.
Yeah, they don't, right? And then so we went back and we built decision tree models, which is simple, right? Works, and it gives you explainability. Because some sensors were really, really freaking good, but the problem was data quality wasn't very high. So we had to kind of iterate and be like, oh, the model did really well. The problem is it doesn't give you consistently highly accurate because these features, these sensor data that is going in is problematic. So we had to filter out, and then we were like, okay, there are second order sensors that are consistent but not nearly as good for the model to generalize, but we will use them. So it went through it, but again, discussions after discussions, multiple iterations, and then the hardest part that we haven't got into is building a model is not that hard actually in today's world, right? Like if you actually have the first principles and the math and a STEM, it's sustaining it, right? Because a Power BI report that you build or a Tableau or a Spotfire, the plumbing is working and things are not, if they break, you know where to look, right? But what if somebody goes and does a maintenance on that and changes some of the underlying features that are required for the model? Right? The model is going to behave completely, the thermal dynamics for some of the sensors are going to change because it's a new part, for example, right? And so that sustainment strategy is where things fall in AI. This is about attrition rate in energy is about 95% of failures, from POC to just dead projects in AI, because the sustainment part is what people haven't figured out yet. And that's kind of, the system changes and the data changes, the maintenance happens, the catalogs, the whole thing, right? That's where the real value is, and that's where people don't focus.
Because the last thing you want to do is have expensive wishes there, making this thing.
You don't know my hourly.
Yeah,
you don't know my
yeah.
hourly or my.
You don't want them managing and supporting this thing 24/7. And so part of it is just educating people on what is actually required to keep this in and to keep value. And not only to keep value for the project, but to build a portfolio that says this function should be within our organization permanently.
Yeah.
And if we teach people how to look at problems differently and to solve those problems, then the value chain of data, and I think that was a bit of a topic, which is what's required upstream, how do you manage the data, how do you get access to it, how do you analyze it, how do you build AI programs, and how do you get those out the door? And every single one of those places, I think, brings value to your organization.
The father of reinforcement learning is actually from University of Alberta, Richard Sutton, right? And so if you understand like how they're going to do this now is the reinforcement learning takes about 1,000 to 1,000,000 times more compute.
Oh, wow.
And what it does is like it basically understands your environment, right? So it's a state machine. So you go from this one position to another, it will learn everything about the environment. It's not like typical pattern recognition. I'm grossly simplifying it. Neural nets are not pattern recognition, but just generally speaking. But reinforcement learning actually learns. And if you look at the words reinforcement learning, it just says that in the name. Like when you see a kid, right, and you have a child, and they're about to fall riding a bicycle, sometimes you let them fall so that they can experience pain. You let them make mistakes, right? Reinforcement learning is built that way, but it takes a ton more compute. We are just literally in the early innings of what's about to come, because that reinforcement learning, when the compute, all these AI data centers get rolled out, right? There's about 140 gigawatts worth of power generation that is in the pipe in North America right now, in US alone. 140 nuclear power worth. That's supposed to come online in the next 10 years. When was the last time we built a nuclear power plant? So now you're going to have a battle between AI data centers, right, who want that gas for their peaker units. Then you're going to have LNG, which is exporting to TTF contracts in Europe, right? And so now you have a mismatch, a battle of gas is starting. And guess who has tons of gas?
Yeah.
Us. We export about 8 Bs of gas, right? 99% of our export goes down there. So it's like bullish gas as well. Like, we got to build a goddamn pipeline for the gas. It's not enough. But secondary of gas, crude and heavy barrels, like drill baby drill, is going to actually end up happening in Canada more than US.
Data in hand, we rock the bytes and we'll take a stand. Calculators flashing like a disco ball. Cold board tech, hey, we answer the call.